Lecture 24. I really hope this is the right number because every time I do this, I'm so scared that I'm going to choose the wrong number that I'm like, ah. And then I'll have to go back and fix everything. That's not fun. Okay, rational equations, part 1. Okay, so first of all, this is kind of an extension of last week when we talked about radical equations, and where the radical equations are right under that SOL point is another objective in the Algebra 2 SOLs called the rational equations. And they pretty much just go one right after the other. So rational equations are like fractions, right? And there's going to be a numerator, there's going to be a denominator, and both the numerator and the denominator, right, the top and the bottom of the fractions, are actually polynomials. So those are coming back again. So let's start off with a definition real quick. So definition. Okay. We're going to define rational equation. Rational equation. Not my favorite type of equations, but they got to be done. Okay. So a rational equation is an equation that involves rational expressions. Involves rational expressions. All right. So this is going to be an equation where you're going to have rational expressions. Now, like I said before, rational expressions, I'll just put a note. What is a rational expression? Well, any rational expression can be written as a fraction. There's going to be a numerator, there's going to be a denominator, but it's basically going to be written as r of x is equal to p of x over q of x, where q of x cannot be 0, of course, because that would be dividing by 0, right? So this is going to be a fraction. Just like we learned in the first few weeks of school, we learned that there are these things called rational expressions that can be written as fractions. And you're going to have some kind of variable expression on the top, and you're going to have some kind of variable expression on the bottom. And usually what happens is you can factor the top by whichever factoring technique we're going to be using, and you can factor the bottom. Maybe the same way, maybe a different way, but usually you can factor the top and the bottom. So let's start off with the first type of rational equation. And the first type is going to be called cross multiplying. Cross multiplying. I'll just put it that way. So when we're cross multiplying, usually you'll see a fraction on the left side and you'll see a fraction on the other side. So you might have something like a over b is equal to, let's say, c over d. So you've got a fraction on the left side and you've got a fraction on the right side. So what can you do if they're both equal? Well, you can do what's called cross multiplying. which is where you multiply A and D, and you set that equal to B times C. So the things that we're multiplying, we're putting in different colors. Okay? So A times D, that's just going to be AD. And that's going to be set equal to B times C. And you get BC. And that's simple enough. Okay. So let's look at an example of this from the problem sets. Let's look at number 1. This is 4 over x minus 3 equals 2 over x. Okay, so for this one, I've got a fraction on the left and I've got a fraction on the right. And this cross multiplying trick only works when you have one fraction on each side. Okay? So what I'm going to do is I'm going to multiply crossways. I'm going to multiply the 4 by the x, and I'm going to get 4x. And then what I'm going to do is I'm going to multiply the other way. I'll have 2 times x minus 3. And what's going to happen there is the 2 is going to be distributed to the x and the minus 3. So let's look at what that's going to look like. So I'm going to have 4 times x. I multiply those. And then on the other side, I'm going to have 2 in parentheses times x minus 3. And I pretty much just go from there. So all we're doing is we're cross multiplying, right? So right now, I can't really do anything with the left side. It's only 4 times x, right? But on the other side, I can distribute. So the left side is going to stay the same. And I bring down my equal sign. So now I have 2 times x minus 3. Well, if I distribute the 2, I'm going to get 2x minus 6. 2x minus 6. And then I just try to get all the x terms on one side, and I try to get all the regular numbers on the other side. So that way I can get x by itself. So to get the 2x over to this side, I can subtract 2x from both sides. So I'm going to subtract 2x from both sides of the equal sign, and we'll see what happens. Okay, so 4x minus 2x is going to give me 2x equals. Now the 2x and the minus 2x are going to cancel each other out, and I'm only left with the negative 6. That negative 6 is going to come down. All right, so I've got 2x equals negative 6. The last thing I need to do is get rid of that 2 out in front, and I can do that by dividing by 2 on both sides. So when I divide by 2, I'm going to get negative 3. So that's going to be my answer, negative 3. I put that in the solution set. All right, so that's cross multiplying. Now the last thing I'm going to do is I'm going to check it. So I'm going to come over on the right side and we're going to check this answer. And the way I'm going to do it is, just like every single time, I keep the original equation the same. I just replace every single x with my answer that I found, that negative 3 right there. So let's go ahead and check it. I'm going to rewrite the original, not plugging in anything yet, just keeping everything the same. So I've got 4 over x minus 3 equals 2 over x. Okay, so I'm going to replace every single x I see with a negative 3. So I'm going to get 4 over negative 3 minus 3, right? I've replaced this x with a negative 3. And then over here, I'm going to replace this x with a negative 3. So I'm going to get 2 over negative 3. All right, so far so good. We're just checking our answer at this point. So now at the bottom of this fraction, I know that negative 3 minus 3 is going to give me negative 6. So I'm going to have 4 over negative 6 equals 2 over negative 3. So I've pretty much almost got it. The last thing I need to do is reduce the left side, because I know for a fact that I have 4 over negative 6, and I can divide both of those numbers by a 2. Okay? So once I do that, I divide the top and the bottom by 2. I get 2 over negative 3. Which is the same thing as this side. So I get a true statement at the very end. So that means that my answer works. Okay? We're going to do another problem that's just like that. And then we're going to move on to other types of rational equations. Okay. I'm going to leave that up there for a minute, and I'm going to find my next question, just so you guys can have time to copy that down and really let it sink in. So all we're doing is we're multiplying crossways. We're multiplying this way, and then we're multiplying this way, and then we're setting the two sides equal and finding out what x is. And once again, this only works if you have a situation where you have a fraction is equal to another fraction. So that's the only time that this kind of method is used, and it's called cross multiplication. Okay. All right, so let's look at another problem that's just like that. Let's look at number 2. Let's do 4 over x plus 2. 4 over x plus 2 equals 7 over x minus 5. Yeah, that's my algebra 2.
Okay, so this can go.
This can go, yeah.
And you found my
Yeah. All right, so 7 over x minus 5 is on the right side. And I have a situation where I have one fraction on each side. So that means I can do cross multiplication. All right, so I'm going to multiply the 4 by the x minus 5. So I'm multiplying these two. And then I'm going to multiply the 7 by the x plus 2. So we're multiplying crossways. So I get 4 times x minus 5 is equal to 7 times x plus 2. All right. So I set them both equal to each other, and now I kind of simplify first, and then I'm going to try and get all the x terms on one side and all the regular numbers that don't have an x attached to the other side. So when I distribute the 4, I get 4x minus 20. On the other side, I'm going to get 7x plus 14. Okay. So I'm going to get all the x terms onto the left side. So that means this 7x has to be able to go over to the other side. Since it's a positive 7x, I can subtract 7x from both sides. So I'm subtracting 7x from both sides. That'll get all the x terms onto the left side. Now for the numbers, I need to get all those to the other side. So that means the negative 20 needs to go over to the right side. So how can I do that? Well, since it's a negative 20, I can add 20 to both sides. That'll get rid of the negative 20. So I add 20 to both sides. So this time I get negative 3x is equal to 34. Negative 3x equals 34. The negative 20 cancels with the positive 20, and the negative 7x will cancel with the positive 7x. Now the last thing I have to do is divide by negative 3. And I get x equals negative 34 over 3. Now notice I can't reduce this, so I have to keep it as a fraction. So in my solution set, I'm just going to have a negative 34 over 3. Okay. So that's how I get number 2. And obviously, if you wanted to check it, you could plug it back in for x and see what happens. But in the interest of time, I'm going to move on to the next type of rational equation. Okay, so for the next types, it really helps to have a list of what you need to do in terms of steps so that it's kind of easier once you see it to be able to get to the answer. So let's talk about what you're about to see. So what you're about to see is a fraction plus or minus another fraction. And whenever you're adding or subtracting fractions, ultimately you need to find a lowest common denominator. So here are a couple steps that you need to follow when you're solving rational equations. So let's take a look at those. Okay, so the first step you're going to do is you're going to factor all denominators. Factor all denominators. That means the bottom of every single fraction. You're going to factor as much as you can. It might be factoring by difference of squares. You might be factoring by rainbow method. You might be factoring by, finding those two numbers that multiply to the end but add up to the middle. But basically, you want to factor as much as you can. And once you're done factoring all that you can, you want to see if you can find a common denominator. So you want to find a least common denominator for all fractions. So once you find that least common denominator, what you want to do after that is you want to replace all denominators with the LCD. So you want to replace all the denominators with the new denominator that you just found, that least common denominator. And you want to replace all the numerators. All the numerators, which would just be the tops of the fractions, right? And then the last thing you want to do is set the numerators equal to each other. And solve for the variable. Solve for the variable. And then maybe the last step is to check your answer. Okay. So those are the 5 steps we're going to be following. Now, when you're solving for this variable, which is usually x, what you might find out is that all the x's just kind of go away. In that case, you might end up with a special type of solution. So here are the special types. All right, special types of solutions. So you might have a true statement, that would mean all real numbers. All real numbers. So an example of this would be like getting 0 is equal to 0. This would be a true statement, right? This would be a true statement if I got something like 0 is equal to 0. Now, if I got something like this, then I would write all real numbers, because every single real number would be a solution at that point. The other type of solution that you might see is a false statement. A false statement. So if you get a false statement, that's going to mean no solution. So you would write no solution, or you could write the empty set. You could write it like this, or you could write it like this. So no solution would be a false statement. And an example of this would be, let's say you get 1 equals -1. 1 equals -1. That's not true. That would be false. So if I got something like this, then I would know this equation has no solution. So then I would write no solution, or I would write the empty set, one of these two. So I'll leave that up there for a minute for you guys to get. So a lot to think about. Okay. We're going to be looking at number 3. And I'll go ahead and write it down while you're copying that. Okay. Let's try this one. Okay. So for this rational equation, we have a situation where we have 2 fractions on the left side, but we only have 1 fraction on the right side. So we can't just do cross multiplication like we did with the first 2. We have to actually add fractions together, right? Now, whenever you're adding fractions together, you need to find what's called the lowest common denominator. Now, the first thing I would do in my little list of steps is I would factor as much as I can. And looking at everything, it doesn't look like we can factor anything, right? So I would just skip to step 2. Since we can't factor anything, I would go about finding the lowest common denominator. So what would be the lowest common denominator? That's a good question. Well, looking at the denominators that we have right now, the first one I see is 4x, 4x, but then I see 3x. And then the last denominator is just an x, or I guess you could say 1x. Same thing, right? So what can all these denominators become? Or put in another way, what can they all multiply to be? They can all multiply to be what? 4x, 3x, 1x. They can all become 12x, right? So my lowest common denominator is going to be 12x for this question. So what I want to do is I want to change every single denominator to 12x. Okay? So we're going to rewrite every single fraction with a 12x in the denominator. So this one is going to have a 12x. This one is going to have a 12x. And this one is going to have a 12x. Because all the denominators have to be the same in order to add or subtract fractions, right? Now, we just changed every single denominator to being 12x. If you change the denominator, that's going to end up changing the numerator, right? But how does it change? Well, how do I get from 4x to being 12x? How do I get from being 4x to 12x? What just happened there? What can I multiply 4x by to get to 12x? Well, I would have to multiply by 3, right? So that means I need to multiply everything at the top of that fraction by a 3. So I'm going to multiply everything at the top by 3. So this x plus 2, it just got multiplied by a 3. Okay. Let's look at the next fraction and see how that changes. How do I get from a 3x to being a 12x? What did I have to multiply by there? Well, I had to multiply by a 4, right? So I'm going to multiply the top by a 4. And then the last fraction, how do I get from 1x to 12x? I multiplied by 12. So I'm going to multiply the top by a 12. Okay. So now I've changed all the numerators. And now what I can do, since I've replaced all the numerators, I can move on to my step 4, which is to set all the numerators equal and solve for the variable. Now, at this point, all the denominators are the same. So I can actually lift the numerators off the fractions that they're on. So let me show you how I do that. What I'm going to do is I'm going to pretend like the denominator doesn't exist at this point. So the top for this one is 3 times x plus 2. Okay? I bring down my plus symbol. The top of this fraction is 4 times x minus 8. And then I bring down my equal sign, right? And then the top of this fraction is 12 times x plus 5. And now I just go from there. So what I've done is I basically eliminated the denominators from the equation at this point. Okay, so now I can pretty much go from there. I can distribute the 3 to everything here, distribute the 4 here, and the 12 here. So what do I get? I get 3x plus 6 plus 4x minus 32 equals 12x plus 60. So now I'm just distributing, right? Okay. Now I can simplify the left side, right? You see the x terms can be put together. So what's 3x plus 4x going to give me? 3x plus 4x is going to give me 7x. And then what's 6 minus 32 going to be? That's going to be 26, negative 26. Yeah, negative 26. And then everything is still equal to the 12x plus 60 on this side. Okay? So I put the x terms together and the regular numbers together. So basically what I did was this and this to get this. And then I did this and this to get this. Meanwhile, the right side over here is basically unchanged. Okay. So now to get x by itself, I can get all the x terms to either the left side or the right side. And then whichever side I didn't choose, I can get all the regular numbers to the other side. So let me see if I can get all the x terms to the left side and then get all the regular numbers to the other side. So I'm going to subtract 12x from both sides. Subtract 12x. And I'm going to add 26 to both sides. All right. At this point, I get 7x minus 12x. That's going to give me negative 5x. These numbers are going to cancel out right here. So I'm not even going to write the 0. Equals. These x terms are going to cancel out. And if I add these numbers up, I'm going to get 86. 86. And then what's the last thing I have to do? Divide by what? This negative 5 right here, right? Divide by negative 5. That's good. So now if I divide by negative 5, I'm not really going to get a whole number on that side, but I'm still going to get a fraction. I get x is negative 86 over 5. There we go. That's going to be inside my solution set. So that's the fourth step in my little list of steps that I made. Now the last step would be to check my answer. I still have another problem that I want to do, but a really quick way that I can just do a really quick check of this answer would be to see if it makes any of the fractions have a denominator of 0, right? Because if I have a fraction with a denominator of 0, that means I'm dividing by 0, right? And we can't have that. So if I plug this in for x in my original equation, I'm not really dividing by 0 anywhere. So that's good. At least I'm not dividing by 0. But this fraction is going to be the answer for this one. Okay. I'll leave that up there. And then we'll do the last one real quick. And then I'll show you what your homework is going to look like. All right, I'm going to write down number 4. So the key to these problems is finding the lowest common denominator. And if you can change all the fractions to having that denominator that you found, you also have to change the numerators accordingly. And then once you do that, you can basically lift the numerators off of the fractions like I did in this step, and then you can pretty much just go from there. Okay, let's look at the last one. This one is number 4. So just like the last one that we did, we have 2 fractions on the left side and we have one fraction on the right side. So I know I can't do cross multiplication, but I can find the lowest common denominator, and I can change all the fractions. So looking at this one, I have an x minus 3. That's on my first fraction. That would be my first denominator. And then on the next fraction, I have an x at the bottom. And then for this last fraction over here, I have x squared minus 3x. Now, this is the one that I'm going to end up factoring before I start. So looking at the first two fractions, I'm going to leave those the same. But for this one over here, I'm going to factor this and see what I get. Now, x squared minus 3x, I know that those two terms have an x in common. So the greatest common factor that I can take out from both of these terms would be an x. So these two fractions are going to stay the same over here. They're not going to change yet, but they will soon. So the left side pretty much remains the same for now. On the other side, I have an 18 on top. And then I can factor the bottom as x times what? What would I be left with if I took out an x? I would be left with x minus 3. So I'd basically be left with that. Okay, so I factored all I could, and now the second step is to find out what the lowest common denominator is. What is the LCD? So I've got an x minus 3, I have an x over here, and this one has both of them. So what I could do is I can change all the denominators to this, right? In that case, this would be my lowest common denominator. And both of these would have to change to conform to this. So my LCD is going to be x times x minus 3. So how is this going to work? Well, for the first two fractions, the denominator is going to have to change. It's going to have to change to x times x minus 3. And this one over here, this one is also going to have to change to x times x minus 3. Meanwhile, this fraction on the right side, it already has that lowest common denominator. So I don't have to change it. It's already x times x minus 3. So I'll leave the 18 up here. Don't need to change that. But the first two fractions, I will have to change the numerators. So how do I get from x minus 3 to x times x minus 3? I would have to multiply by x. So at the top, I'm going to have 6 times x. Over on this fraction, how did I get from this to this? What did I multiply by to get from this to this? I had to multiply by the x minus 3. So I'm going to multiply the top by x minus 3. Okay. So now all the fractions have my least common denominator. That's good. And all the numerators have been changed. So now what I can do is I can lift off the numerators from their denominators, right? So let's lift those off. I'm going to have 6x minus 6 times x minus 3 equals 18. So now I'm just considering the numerators. I'm not considering the denominators anymore because they're all the same at this point. Okay, so now I have something that I can easily solve for x, right? I would just have to simplify a few things first. This 6x is going to stay the same. I would have a minus, and then this 6 would have to be distributed to everything on the inside. So I would have a 6x minus 18 is equal to 18. Okay. And since I have that minus out in front, that's going to also distribute to everything on the inside. Okay. So I'm going to have 6x minus 6x. And then I have a minus minus, which of course is a plus. So plus 18 equals 18. Okay. So now I have a situation where the x terms all end up on this side, and I still have an 18 on this side, but I'm not going to change that yet. I do know that 6x minus 6x is going to cancel the x terms out. So the only thing I'm left with on the left side is the 18. The only thing I have on the right side is 18. So I have 18 equals 18. All the x terms cancel out. So does 18 equal 18? Yes, this is a true statement. So this is one of those special types. Now, if it get a true statement, that means that I would write all real numbers. So inside my solution set, I would write all real numbers. So what this means is any real number that I can think of, whether it's -3, +2, 1/2, square root of 3, pi, whatever real number I can think of, it would actually be a solution to this original equation, no matter which number I choose, even if it's 0. But then I'd be dividing by 0, right? So I can't have a 0. I can't have a 3 either. So maybe all real numbers except for 0 and 3. So you could say all real numbers except for 0 and 3. But those are the only exceptions. Any other real number besides 0 and 3 should be able to solve this. So I would say this would be my answer. All real numbers, except for any number that would make the denominators 0.